Good day to all. This is Dr. S. Rajesh Babu from the Department of General Engineering at Kamaraj College of Engineering and Technology. I am going to deal with virtual systems. Virtual instrumentation is one such theme which integrates software and as well as hardware. In today's industrial expectation, these type of virtual instrumentation will help to reduce the lot of resources where the resources will be get wasted. These resources can be used optimized with the help of these virtual instrumentation. So the definition for the virtual instrumentation are the one which combines software and as well as hardware equipments. It consists of servers, storage devices, and networks, and enables more resource utilization in the industries. The importance of virtual systems in the today's technologies, we have a excellent resource optimization, and then we have a good cost efficiency where all the industries are focusing towards the cost efficiency, and it has a good scalability limits, a good flexibility, and as well as it also helps us to recover from any disaster that happens in the today's market. The types of virtual systems will have three different modules. One is virtual machines, virtual networks, and then virtual storages. The origination of these components will have a good history. In this video, we are going to just see how the virtual instrumentation it rose, and then how they are used in today's industries. The virtual networks is a network where the software manages the network's functionalities and as well as the services which is offered for a system. And virtual storage devices, which will have a storage equipment that stores a number of data. That data can be utilized, optimized, and optimized the contents. With this, we have a simple introduction about the virtual instrumentation, where virtual instrumentation will try to integrate all the software and as well as the hardware equipment in an appropriate manner. They are the essential need of today's industry. This is a basic block diagram of virtual instrumentation, where we use these type of instrumentation in order to have a good production in the industries. As far as the virtual instrumentation is concerned, today we are in a situation to have a good opportunity to earn the productivity in the industry. In the earlier beginnings, it started in the year 1970 and evolved in the year 1980, and it was rose in the year 2000. So this is a milestone of virtual instrumentation, where here earlier the traditional instrumentation will have a vendor defines the control and functionality, where now the virtual instrumentation has transformed the work into the user integrates the defines the functionality through the softwares. This is a basic block diagram of a virtual instrumentation which has a sensor. The sensor is nothing but the primary sensing element which is present inside a network, and where it senses what type of data is present here, whether the data is in the form of physical quantity or in the electrical quantity. If the form is in a physical quantity, it may be a pressure, it may be a temperature, or it may be pressure as well as the other physical parameters like weight. And if you consider with the electrical quantities may be voltage, current, or power. Next comes to the signal conditioning unit, where it will converts into a definite form of a signal. The sensor will sense the signal, it may be in a irregular form, it will be converted into a definite form of signal, then the signal will be converted into a digital form, which is now very essential in order to have a good accuracy. Then other signals will be processed based on the requirements. We will control the signals and we will make the signals into a definite form. So this is a general overview of virtual instrumentation, where the interfaces we use here is Ethernet, USB and 5R. These are some of the interfaces that we use in today technology. So earlier it was used in a different fashion, where in the year 2000 we started to promote those virtual instrumentation into a different phase. So in this year there was a drastic growth in the data acquisition system, where data acquisition system collects number of data from one end to the other. It transmits the data from one end to the other. It also have a good connection from one end to the other end. So with the help of the data acquisition system, we can control, we can analyze all the data which are present in distant places. In the modern era, we have one more facility, where nowadays we use these type of technologies. We use cloud and IoT integration with the virtual instruments, where the instrument will be placed in one end, but it will be observed from far places. Virtual instrumentations in the cloud is also present in this current technology, where it offers a good role in the field of automation too. So for using virtual instrumentation, we have one important software, that is nothing but LabVIEW, where it can be used for both software as well as hardware control. So it has a LabVIEW, MATLAB, and we use Python. The hardware equipments that we use here is data acquisition system and PXI systems. The communication protocols, we use GPIB system and USB system. So these are some of the software and hardware equipments that can be used in virtual instrumentation. So the example for virtual instrumentation here is, you can use the virtual instrumentation in the field of manufacturing. We can use the virtual instrumentation in the field of environmental modeling. We can use this virtual instrumentation in the field of remote laboratory experiments, even in education systems. Of course, you are aware about the COVID situations which was present in the year 2020. At that time, this virtual instrumentation offered a better promotion for in the field of education. So key benefits of this virtual instrumentation are cost savings, the flexibility in their work, and you can also scale your work, how far you have done the monitoring and as well as the process, and you can use for data analysis and as well as the visualization. The challenges what we face when we use any technology, whatever the technology we use, the technology will be changed in a frequent manner. So the challenges what we face when we use these type of technologies are initial setup and learning the process how to use those technology. That is what the first challenge. And then the next challenge is, if we integrate the existing system, we need to troubleshoot all the problems which are associated with the existing system. And then data security and security concerns are so quite be present in all the virtual instrumentation process. In the future trends, it increases the use of artificial intelligence. Now artificial intelligence are used in large scale, where it is applied in all the fields. Those artificial intelligence tools can also be implemented in the field of virtual instrumentation, and it can also integrate with the cloud computing, and the advances in sensor technologies and as well as connectivity will also have a good future in this field of virtual instrumentation. The advantages of virtual instrumentations are cost efficiency. I already told that it has a good flexibility and scalability, where it has a good data analysis. So these are some of the advantages, where this virtual instrumentation will have a good monitoring process. Let me see a simple case study where the virtual instrumentation are applied in real world. So, in the real world applications, we have some applications like automotive testing, environmental monitoring, and as well as the industrial automation process. So, I have a case study here. In order to explain this case study, first let me have a simple introduction about the case study, right. In the field of virtual instrumentation, we require first data. What is the data that we need to analyze, and what is the process that we are going to do. So, these two things that need to be very clear whenever you implement in any process. So, I am going to apply here for an automotive process. In this steps, we have a number of initial steps that need to be followed, and then we need to execute the actions whatever we require in the field of automation. Here, the different type of tests that can be done with the help of virtual instruments are: first one is engine performance testing, emissions testing, braking testing, and as well as the suspension and vibration analysis. So, in the first process, we measure engine power, efficiency, and as well as the response of the engine. In the second one, it evaluates the level of pollutants emitted by the vehicle, and then the next one is brake testing. It assesses the efficiency and reliability of the braking system. At the last, suspension and the vibration analysis that need to be done for all the vehicle in order to have a good suspension in the vehicles. So, when we do engine performance testing, this is a first process where we test the engine power, efficiency, and the responses under various conditions. The vehicle will be run at different conditions. It will be observed, and then those observations will be recorded in a data acquisition system that will be transferred to other point where you will access all the data which is produced by the engine. The key benefit that we produce in this process is we have accurate measurement, we have a good real time analysis, and as well as we can able to simulate the different scenarios. When we do these type of simulations, definitely we can use the virtual instrumentation in an appropriate way, so that in real time cases we will not have any flaw in the working condition. So, when we go for emission testing process, it measures the amount of pollutants. So, usually the virtual instrumentation will have the sensor and the data acquisition system to monitor how much gases are exhausted from a vehicle. And then the benefits from this type of testing is we can have a good engine without any pollution. The last one is braking testing. In this test, we will evaluate the performance and reliability of the vehicle braking system, where we will use the same sensors in order to have a perfect measurement in all the process. So, we have a benefit of improved safety and accurate measurement in the brake testing process. And last one is suspension and vibration analysis. In this process, we will analyze how far the vehicle suspension system and the ride comfort is present in a vehicle. Usage of those virtual instrumentation were accelerometers and data acquisition system for this process, and then we have an enhanced comfort and identification of issues with the process. So, the benefits of virtual instruments in automotive testing is we have a good real time data acquisition analysis, cost effectiveness, and as well as flexibility in the work. So, the challenges that is present in the vehicle performance monitoring is we have a potential challenge. Initially we need to have a good setup for testing a vehicle, then a compatibility issue, as well as the data security, whatever the data that we try to measure that need to be safeguarded. If it is promoted or if it is transferred to other one, then the engine data can be easily stolen by the competitors. So, we need to take care of the data securities too. So, the considerations were proper planning, and then we need to have a regular updates on the performance of a vehicle. So, for this I have used a Python code which help us to identify how far the engine performance is present. So this is a basic Python code which is used to assess how the system will work in terms of simulations. So you can see that engine performance testing is done with the help of a simulation module, where I have not included any hardware module here. So that's what the challenge I said, right? So here I have implemented with the help of a software code. This software code indicates how far the system is present. So in this performance, you can see that the characteristics is drawn between speed as well as torque and power. If you see that whenever there is a rise in torque, there exists a rise in power, mechanical power, and you have a small dip when the torque is get reduced. So this is a performance curve of an engine, and then in addition to that, we have brake test. In that brake test, we have observed the performance between the time as well as the brake force and the deacceleration. So whenever we need to produce a brake, we need to have a good deacceleration. So the deacceleration process will be increased. Due to that, the brake force will be drastically reduces. This is what one more performance which is observed in software. So this is one basic case study, and then the next one is we have an example for air quality monitoring. This is also one of a application of a virtual instrumentation, where it is used to monitor the air pollutants which need to be monitored by the people.